So now that we've discovered the unit circle and what it is, how do we actually practically use the unit circle to help us with finding sine and cosine and tangent for all these angles that are bigger than 90 degrees, the negative angles, and all of that kind of stuff? So that's what we want to look at today. So the first thing I want to say is that as you're starting, if you have a unit circle that you filled out yesterday, having it next to you, that's what you're going to use as your calculator. When we start getting into pre-calc and when you're over at NC State taking math classes and you're not allowed to carry in that reference piece of paper with you, then you're going to want to make sure that you do actually have the unit circle memorized. And I'm going to show you some tips and tricks on how I have used it in the past without having to carry one physically around with me. So if we are looking at trying to find the sine of 225 degrees, all right, and that's just the problem. I need to find the sine of 225 degrees. I don't know what it is. When I'm trying to find it on the unit circle, again, if I don't have a unit circle with me, I just draw a circle. It doesn't have to be perfect, and it doesn't have to be very big. I just draw it small, and then I put in my lines. I know I need 3 over here. Notice they are not perfect. That's okay. I just need them to help me count. And so what I'm going to do is I'm going to say, okay, well, I know this is 0, and I want to know where is 225 degrees. So I've got 30, 60, 90. Oh, wait a minute. If I count by 30s, I'm never going to get a 5. Let me count the 45s. That's the only way I end up with a 5. So this would be 45 degrees, 90 degrees, 135 degrees, 180 degrees. Aha! Here is 225 degrees. So once I have discovered where it is on the unit circle, then I can figure out which is its reference angle. This is the 45 degree angle. So that goes with the middle line. All these middle lines, the pink here, these are all those 45 degree angles. They're the ones that use the same coordinate point. And that middle point was the square root of 2 over 2. It was the 45 degree angle. It was the 45, 45, 90. It had the same coordinates. So if I'm in this third quadrant, it's going to be that point, but they're both going to be negative. Now again, if you've got your reference unit circle in front of you, you just needed to find 225 degrees, and then you found that this was its point. So the next thing I have to remember is I'm looking for sine. So when we look at the coordinate points, cosine is the x and sine is the y. So that means that the sine of 225 degrees is negative square root of 2 over 2. All we're looking for is, this is our calculator. It's doing the calculations for us. So if we can find the point on the unit circle, then we know it's sine or it's cosine. So the sine of 225 degrees is the negative square root of 2 over 2. They can always give us things in radians, so they could ask us what is the cosine of 4 pi over 3. 4 pi over 3. So if I wanted to find 4 pi over 3, I've already drawn my unit circle once, so I don't need to draw it again. I'm counting by thirds, so the only way I got thirds is if it was the 6th. It reduced, right? It must have been one of the ones that reduced. So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 8/6, 8/6. That reduces to 4/3 pi. So that's this angle. So I found 4 pi over 3. I found where it is on the unit circle. And so then I have to figure out what is its reference angle. So it's the one that ends up being right next to the y-axis. All of these yellow ones, these are their reference angles. They are all the same triangle. So that means it goes with this point. And this was the one that was 30, 60, 90. And so the short side is the x-axis, so that makes it 1/2, and the long side was the square root of 3 over 2. But I'm also down here in the third quadrant, so that means they're both going to be negative. So it'll be negative 1/2, negative square root of 3 over 2. And since I'm looking for the cosine, cosine is the x value, and the x value is negative 1/2. So that means the cosine of 4 pi over 3 is negative 1/2. Now, we also learned last week that you can go around the circle more than once. We could have a very large angle of some sort. So let's say I was asked to find the sine of 750 degrees. Well, that's really big. So I'm like, okay, if I start here at 0 and go all the way around, that's 360. And if I go all the way around again, that's another 360. And so 360 and 360 is 720. So I need 30 more degrees. So I end up here. So this is where 750 degrees would be. And if I now know that this is where that is, I need to look at what are my reference angles. So this triangle is the one that flips closest to the x-axis. So all of these are going to use the same point. And it was also the 30, 60, 90, but it had its short side at going up and down. So it was the y-coordinate. And this one is in the first quadrant, so I'm just using this one. So the sine would be the second one. Sine is always second. So that means the sine of 750 is 1/2. Now, what if we wanted to find the cosine of negative 180 degrees? And we were trying to figure out what that is equal to. So here's where you do have to make sure that you're paying attention. If the angle is negative, it's not telling you that the sine or the cosine will necessarily turn out to be negative. It's telling you that you're counting your angle going clockwise instead of going counterclockwise. So when I look for negative 180 degrees, instead of going this way, I am going to go this way. Now for 180 degrees, that actually doesn't make much of a difference because when I go 180, I get exactly halfway around the circle. And this is the point that is negative 1, 0. So if I want cosine, cosine is always the first one. So that means that this is equal to negative 1. I could look for something like the sine of negative 60 degrees, right? And so instead of going up to 60 degrees here, I'm going to count by 30s down this way. So this would be negative 30, negative 60. So this is negative 60 degrees, which is going to be the point 1/2 negative square root of 3 over 2. And since I'm looking for sine, sine is the second one. So that's going to be negative square root of 3 over 2. So this is how we use the unit circle to find sine and cosine. What we haven't talked about yet is tangent. How do we find tangent when we're dealing with the unit circle? Because you might notice the lack of tangent on the unit circle. So we need to think for a second about what tangent is equal to. Tangent is the ratio of the opposite over the adjacent. And so the opposite side is from the angle is always that y-coordinate, and the adjacent side is always the x-coordinate. And so that's why we can actually say, because we're using the unit circle and the radius is just 1, tangent is actually equal to the sine divided by the cosine, because we know that the x-coordinate is the cosine and the y-coordinate is the sine, so tangent is equal to sine divided by cosine. So we can still use the unit circle to help us find tangents. If I wanted to find the tangent of 2 pi over 3, or 2/3 pi, all right, so I'm doing 1/3, 2/3. 2/3 is right here. So I have the cosine and the sine. I just need to do the sine, which is square root of 3 over 2, divided by the cosine, which is 1/2. Now, it does mean that we're going to be dividing fractions a lot. And if you recall, writing fractions this way to do division is not very useful. So I'm actually going to say, okay, so it's the square root of 3 over 2 divided by 1/2. And when you divide by fractions, remember we keep change flip. So this is going to be the square root of 3 over 2 times 2 over 1. So my 2's will cancel out. And the tangent of 2 pi over 3 is just the square root of 2 because it's equal to the sine divided by the cosine of 2 pi over 3. So when you're asked to find a tangent, all you have to do is still use your unit circle, find the point, but instead of just using the x-coordinate or just using the y-coordinate, we're actually going to use both the x and y-coordinate, and you're going to take the y-coordinate and you are going to divide it by the x-coordinate because that would be your opposite over your adjacent, and that's going to give you your tangent. So we can use the unit circle to help us find sine, cosine, and tangent.